Good morning, class. Today, I thought we'd go over our predicting products quiz and how we got the answers. This quiz wasn't as much as a smashing home run as all the other quizzes and assignments have been, but that's not a bad thing. That's just to say that I finally found something that we are going to actually have to work on. That'll challenge us a little, and that's totally all right. Predicting products is a little bit of a challenge, and it is 100% okay for us not to get it right away. Let's go through some of these answers and figure out, well, how did the answers turn out to be exactly what they were? So here are the questions. I have them listed, all 6, and we're going to work through them one by one to see how do I predict these products and what steps do I end up taking. One of the things that you're going to need handy is you're going to need to have your periodic table handy along with a list of polyatomic ions to be able to do any of this. So if you tried to do it without that sheet, that's probably one of the things that would really help you do this better. Let's go ahead and get started. So first thing, I see I have some lithium bromide and some cobalt sulfate. These are both compounds, and since I have 2 compounds that are reacting, I'm going to suspect that this is a double replacement. And I remember my rule with double replacement is that the metals swap partners. So what I need to do is I need to break things into my ions and then swap partners. So let's start with lithium and bromine. Lithium bromide splits into lithium, which I know is a 1 plus because it says so on my periodic table, and I know there's bromine, which I know is a 1 minus because it says so on my periodic table. And now looking at the cobalt sulfate, but cobalt is a multivalent metal. So I don't know what its charge is right now, but I do know that sulfate is a polyatomic ion, and that polyatomic ion has a 2 minus charge. Now, how is that going to help me find out what cobalt is? Well, notice how I have 2 sulfates, and if I have 2 minuses, that's a total of 4 minuses. So this 1 cobalt has to match it. Therefore, that means my cobalt is a 4 plus. I have a 4 plus cobalt and a 2 minus sulfate. Now let's look on swapping partners. I'm going to start with my insides. See, so bromine and cobalt are going to become buddies. Cobalt is here, and bromine is there, but it's not done yet, because remember, you always need to make sure that you have the right charges. So cobalt is a 4 plus, that's going to cross over. Bromine is 1 minus, it's going to cross over. So it's COBr4. Now for our next step, we're going to combine lithium and sulfate. Combine those together. So it'll be plus, and then taking a look here, lithium is a 1 plus, sulfate is a 2 minus, so we're going to have 1 sulfate and 2 lithiums, Li2SO3. So that's how we get the answer for our first question. We identify it's a double replacement, we break it into its ions, and then we swap partners. Let's see what's going on for our second question. We have cesium and oxygen. Now there are 2 likely options from this. Seeing this O2, you may think something's reacting with oxygen gas. This is combustion. But remember, our combustion rules work with organic compounds reacting with oxygen. Cesium, Cs, is not an organic compound. It's just an alkali metal. So I have an element of cesium and an element of oxygen. That means this has got to be a synthesis. And a synthesis is just going to cram them together. They're just going to react together. So I know I'm going to have Cs and O shoved together. But the problem is I don't know how they're going to combine yet. So I need to take a look at their ions for me to figure this out. Cesium is an alkali metal. Cesium is a 1 plus. Oxygen is a 2 minus. So I have 1 plus and 2 minus. That's not going to balance. We see I'm going to need 2 pluses to match those 2 minuses. So this is actually going to be 2 cesiums plus 1 oxygen. And that's how I find my products for my second question. Now, if you're saying right now, Mr. Westergaard, okay, sure, I get those charges, but this doesn't work. You have 2 oxygens on the reactants and only 1 oxygen in the products. You have 1 cesium in the reactants and 2 cesiums in the products. You're not following the law of conservation of mass. You're right. I'm not. What I would need to do is I would need to balance the whole situation. You're right, I need to have 2 oxygens in my products as well as my reactants. So I would do a coefficient of 2 to make those 2 oxygens in the products match the 2 oxygens in the reactants. But that means now I have a total of 4 cesiums in my products, so I'm going to need 4 cesiums in my reactants. If you're looking at the subscripts to cram your things together, you need to instead think of their charges. It's always about their ions, and those lowercase letters can always be worked out by balancing the equation afterward. Let's take a look at our third one and see what's going on here. We have aluminum chloride reacting with cesium. Aluminum chloride is a compound, cesium is an element. That is a hint that this is going to be a single replacement reaction. And what happens in the single replacement reaction is that the similar types of compounds are going to replace each other. So aluminum is a metal and cesium is a metal. Cesium is going to replace the aluminum. It is not going to replace the chlorine because cesium is a metal and it will only swap places with the metal. All right, so how do we do this? Again, split everything into its ions. Aluminum is a 3 plus ion. Chlorine is a 1 minus ion. Cesium is a 1 plus ion. With that being the case, you can combine the cesium and the chlorine. Each of them is a 1 charge, a 1 plus and a 1 minus, so that will combine very nicely. And what are we left over with? We're left over with just aluminum. It's just aluminum. And that's how you predict the products for that single replacement reaction. All right, let's scroll down and look at the next 3 problems. So with this next one, C6H12 plus O2, this one is reacting with oxygen, but that's a compound, and that's a compound starting with carbon. That's an organic compound. An organic plus an oxygen is always a combustion. And combustion has the easiest rule to remember. Combustion reactions always make carbon dioxide and water. That's all the thinking you need to do for this problem. Moving on, magnesium iodide and manganese sulfate. That's what we have here. 2 compounds. This looks like another double replacement. So let's split everything into their ions. Magnesium is a 2 plus ion. Iodine is a 1 minus ion. Taking a look at my periodic table, I see manganese is a multivalent metal. I don't know its charge right now. Sulfate is a 2 minus again. Look, I have 2 minuses, means a total of 4 minuses, and I am only using 1 manganese, so that means that 1 manganese has to balance it with 4 pluses. It is a 4 plus manganese ion. Now let's combine our insides. We see we have manganese and iodine. So you write the metal first. And I'm going to need 4 -1 charges, 4 iodines to match those 4 plus charges of the manganese. What about magnesium and sulfate? It's a 2 plus and a 2 minus, so they combine in a 1-to-1 ratio, MgSO3. So there's our second double replacement. Hopefully that one seemed a little easier now that we had practiced our double replacement earlier. NO2. This is NO2, and that's the only thing. If there's only NO2, the only thing that this can do is decompose. And what is it going to decompose into? It's going to decompose into nitrogens and oxygens. And if you wrote that as your answer, you ended up getting it wrong. What's wrong with that? Well, unfortunately, this doesn't remember that both nitrogen and oxygen were considered diatomic molecules. So they need to be N2 and O2 because they are both diatomics. I hope that going through the answers here helped us see what we might have done wrong and what might have went right for us, and helps us predict products more as we continue to practice this in our chapter. Thanks everyone. Have a good day.